Right. Good morning. My name is Gytis Baravykas. I'm a student at TU University, and today I'll be presenting our research paper on assigning different activation functions in artificial neural networks with the goal of achieving higher precision and accuracy. So the main hypothesis was to instead of applying one activation function to a network or to a layer of network, we could assign to each neuron or a different part of the network in achieving a greater result. And we quickly got to work in analyzing the literature, and studies have shown that like image processing or natural language expects some sort of activation function related to the task. For example, image processing has a hyperbolic tangent for most accuracy. Many papers also include a custom activation function that is a combination of two, like rectified linear unit or hyperbolic tangent, and also some research papers underline a need to change an activation function to achieve better results. But the interesting part that there were like no research papers on changing the actual activation functions per neuron or per convolution and similar parts. So we were like very excited to get to work, and so we chosen like a bunch of fields that we wanted to test, and we started from the simplest is tabular data with breast cancer and iris flowers data sets, then image with starting with a simple one, which is a German traffic signs data set, and CIFAR 100 is a bunch of classification for images, then segmentation and time series. So we want to cover as much of machine learning, let's say, prospects we could, and we defined the structure like because of neural networks, there are several types, like convolution neural networks, simple neural networks, and some of them have linear layers of neurons. So we can example that each neuron has its own neural network, activation function. And going forward, we devised a variation for convolutional neural networks, which is per convolution channel, and then through a matrix column. And another idea was to combine both, to have both in convolution and in linear layers a different activation function. And here are the breast cancer results with the baseline simple neural network, which only has one layer and 12 neurons. It's quite a good result already, and we achieved even better results by applying different activation functions. It's not a big increase, mind you, but still an increase nevertheless. And another prospect of this research was to assign a whole list to each activation function per neuron, achieving even higher accuracy than before. Then we have stock exchange, the same approach, better results. Then we had a LSTM model on our custom solar panel generation forecasting model. In this case, we didn't achieve better accuracy, but we achieved the same accuracy as using one activation function. Going forward, we go into image classification with a simple convolution network. So we do see a slight increase in the accuracy, which is not very notable in this case. And then a CFAR with the LXNet, which is one of the most popular functions used on this data set. And we can also see like a very slight improvement, like of 1 or 2%. And ResNet as well, with different combinations of neural networks. Then UNet is astoundingly the most prominent in this scenario because it achieved like a 10% increase while changing different activation functions. And so that's the conclusions that in some cases we achieve like a very low 2% or 0.5% of accuracy increase. But it's important to note that these tasks are already in the 90 above accuracy range. So 2% increases could be a very big difference. Also, like defining a full list can encapsulate the features a lot better. That's what we found. So that's a further research topic that is interesting. And also segmentation tasks is something that's very interesting and could be further researched. Yes, so that's my presentation. Thank you.
Thank you very much.